Hello guys, welcome back, and today we continue our mathematics study. Let's talk about chapter 5, exponential and logarithm functions. Okay, I know sometimes people feel this chapter is a bit hard because you only learn these two types of equations or functions from year 11, not like the polynomial or linear equations we covered like long time ago, since like year 7 probably, or even year 9, year 10, right? So let's go through this one slowly and help you guys to nail it down, and let's do it. Okay, so the first one is, what is exponential functions? Okay, so exponential functions has a rule for the form like fx equals k times a to the power of x. So now this time our x is on the power instead of on the base, right? And let's look at 5a. So the exponential function is normally just like a to the power of x. And for our a value, we constrain they are just r positive, which means 0 to infinity, but we don't want 1 in here, okay? Because if we include 1 over there, we actually get fx equals 1 to the power of x. Essentially, it's just straight line. So it's not really important or not really useful for us to analyze the general shapes or the graph, right? That's why we only have a greater than 1 and a greater than 0 or less than 1. Okay, these two types. So for the first one, a greater than 1, sometimes you feel like, so I don't know how to draw the graph or something like that. So, but we always can make our life easier by what? By special case, right? So y equals 2 to the power of x. Just use this one. This one, which a equals 2 greater than 1. Okay, makes sense? So now we just use the method we used a long time ago. Okay, this is x, this is 1. So I plug a number, -1, -1, 0, 1, 2, blah, blah, blah. Then I just keep rest of the number in. This one is a quarter, half, 1, and 2, and 4, right? So once I plug in the number, then I draw the graph. It's gonna look like exactly this. Okay, so in here again, I can draw y equals half of x, same thing, right? But if we look at these two graphs, they actually have one thing, okay, it's pretty important, is, do you still remember x to the power of -1 equal 1 over x? Correct, right? So my half can always equal to 2 to the power of -1. Make sense? So I make my half be the 2 to the power of -1, then my x over here, and it's become 2 to the power of -2x. So once we have this expression, let's look at over here and over here. That reminds you something about chapter 3, transformations. Okay, I hope you guys can see it in this way. Basically, this is the meaning is symmetrical or reflection in the y-axis. Okay, let me repeat again. This means reflected in y-axis, right? So if I draw this one, I copy this one over here, it's gonna looks like this. Okay, I just copy it down over here. So for these two graphs, the purple one and the right one, they are just symmetric about the y-axis. Okay, and once you know that, of course, again, we lack transformations, and now we can perform it under the exponential functions. Okay, sometimes you're gonna say, sir, it's pretty hard, to get the idea or do the transformations, but don't worry, we always can use some special numbers or special points to help you to define the graph where it is. But before doing that, you have to make sure you know the basic graph looks like, okay? So in such case, we know the asymptote will be 2 because the overall thing is always greater than 0, so you draw the negative 2 over here. Then again, you see the base is greater than 1, so it must be look like this, okay? So you combine these two conditions, you can get the graph. But of course, you need to calculate the y-intercept or x-intercept if we have it, okay? Let's keep going. The reflection in the x-axis, x stay the same, but y becomes the negative, right? So in here, if you really don't know what's the negative gonna do, we just plug numbers, okay? So before y equals 3 to the power of x, when x equals 0, my y is 1. But in here, when x equals 0, my y is negative 1. And again, we can plug these kind of numbers to give us the ideas. That's why they just tell us the reflection of key points, okay, to help us define where our shape is. That's why, again, they use some special points or coordinate to help us to do it. But of course, never try the really weird or nasty numbers. For example, you can say, sir, I like the square root of 2, so I plug in square root of 2. What's the answer? Sorry, I don't know. Okay, you only can use CAS to help you calculate this type of numbers. So our favorite number is like 0, plus minus 1, plus minus 2, something like that. Okay, it's easy and you can calculate in your head. You don't need really write down anything, right? And again, this one is reflection in the y-axis. So like what I said, y equals half of x, actually 2 to the power of negative x. So it means 2 to the power of x. Just do the reflection around the y-axis, okay? Let's keep going. The next one is dilation, okay? This is our dilation vectors. Just make sure you know how to draw it, okay? And next one is a combination of transformations. So for before we're doing the combinations, actually this chapter revise all the DRT, right, Dr. T, to help us familiar again with our chapter 3. So in here, combination of transformations is more like the revised everything we covered or refresh you guys' memory. So in final year exam, the exponential functions or log functions, again, will be combined with our transformations to test if you understand. Okay, just make sure you look at this example 6 in details. And this is our 5A. Okay, now our 5B can be introduced in a really short way. It's natural log, okay, which is start with the E, okay, and E is like the natural numbers is from this definition. If you think it's really hard to understand or something like that, so just make sure you know E is approximately 2.718, then it's enough for our high school. Okay, you don't need to know where it comes from. You just need to know E is approximate 2.72 or 2.178. So the graph will be quite similar with 2 to the power of x and 3 to the power of x, because essentially e to the x is approximately 2.718 to the power of x. So the graph will between 3 and 2. Okay? Then you just like draw the graph as required. Just imagine e is just some numbers, but we don't know. And actually, if you really want to know what's the application for this natural number or e, you just can read this paragraph for the compound interest to notice in theoretically how much you can earn per year or per time. Okay, that is the 5B. So for today's lesson, we actually just covered about some definition about exponential functions and the natural number, which we called like E, okay, Euler's number, okay, natural base. And for the next videos, we're gonna talk about the calculations for exponential functions and give you guys some trick questions to test if you can really apply what we covered in next video. Okay, guys, just make sure you know the basic graph for exponential functions and to sketch it, to familiar with it, and make sure you can combine with the transformation we covered in chapter 3 to help you or to guide you to draw the required graph. Okay, that's it for today's short video, and if you think my video helped you a little bit, just click the link and subscribe. Okay, I see you guys for the next video. Bye bye.